as basically someone who's helping to continue Judah Folkman's legacy and heading the interim director with Marcia Moses of the vascular biology program at Children's, we have about 125 people that focus in some way on angiogenesis, the growth of blood capillaries, and how that could be targeted for therapeutics, diagnostics, device development. And we have about 1,000 patents that have been submitted from this group, about 250 issued. There's been something like close to 20 licensing agreements, hundreds of thousands of patients who have actually been on FDA-approved drugs that came out of this group. You know, the most notable areas in the past have been development of anti-cancer drugs that treat cancer by preventing capillary growth. Out of the discoveries of the group were drugs that also inhibit macular degeneration and blindness by inhibiting capillary blood vessel growth. But there's work in terms of you know, hardening of the arteries and atherosclerosis, weight control, diagnostics for all types of cancers, prognostics, the ability to be able to predict before you know you have a tumor, that you have it and start treating it early. So there's a huge range of work there. My own work spans more towards bioengineering and the development of devices, some of which that act like microcapillary systems, but we combine them with sort of new wave nano biotechnologies, and we can develop ways to, for example, working on something to clear pathogens from the blood to treat babies with sepsis. There are other members of the group who are working on and have developed new clinical therapies in children to, for example, Mark Puder in our group developed a therapy that just literally uses omega-3 oils, the ones we all pop in our fish oils, but it turns out it saves the lives of babies who have liver failure due to follow-up of having intestinal surgery. It's an incredibly wide range because we work on sort of a fundamental problem. The vascular system, blood vessels feed every organ. They're part of a huge number of diseases you might not think related, from blindness to psoriasis to atherosclerosis and arthritis. So essentially I think it's an example at Children's of how you have people that, we have a program that has from fundamental engineers and biologists to clinicians, surgeons, and people involved in medicine, and together we span the whole gamut. I think what holds us back in terms of science and technology is funding. I think not only is there not enough of it, it's not the type you want. So government funding tends to be funds status quo, quality work, incremental advances, what we've done in the past, and now it's getting really hard to get because of the current, the war in Iraq. And what we really need is work that allows us to do adventurous, high-risk, experimentation, follow people's ideas and passions. So that's one thing holding back. I think in the past it's been hard sometimes to develop formal alliances between different institutions, but that's really changing. I think the landscape is changing. This Institute for Biologically Inspired Engineering at Harvard that I'm now trying to get up and running with people across Harvard and the hospitals is really, we're trying to develop it explicitly to go across all those boundaries and to leverage Boston. CIMMYT does the same thing. It crosses all the hospitals, Harvard, MIT, BU. So the scientists will naturally just follow their passion and just do it. It's mostly the funding challenge, which comes from the government funding and venture capital getting so successful that no longer wants to fund early stage stuff. So and big pharma also being, rather buying small startups. So there's a void right now that we have to get through the next 10 years, I think, before we get back to a sort of a blossoming again. I think most scientists I know really are concerned about America's technological competitiveness, because we know that that's where the American economy, the lead we have economically is based on investments in science, engineering, and technology from the Sputnik era through the 80s and 90s. We see that ending or dropping off precipitously. We see, other nations from a little tiny nation like Singapore to a big one like China, putting billions into this as their future and education of their young people in science and engineering and technology, which is probably our biggest worry, is that you don't see many American kids going into it. But I think that we really need support from the state and from the federal government to foster collaboration and innovation and translation, but not just the end point, the whole process. These things take 30 years. And to realize it's not just one opportunity like stem cell or gene therapy, but it's really technology in its widest definition. So I think that's an opportunity that we have, and if we don't pursue it, it's the fall of the empire, at least in my view.